This is the table of all the angles that to be taken into consideration. Just note down all these. But as per your syllabus, all these things are not there. Only one thing is there in your syllabus, that is 90 minus theta angle. Other than that, no angles are there. So only take 90 minus theta as your syllabus. Others are not necessary. So I will be taking 90 minus theta and solving problems on this concept. So what are the 90 minus before going into problems? Once I am going to revise that thing. First one is sine of 90 minus theta is equal to cos theta, and cos of 90 minus theta is equal to sine theta. Similarly, write the other things also. Done. Secant of 90 minus theta is equal to cosecant theta. Using only in your syllabus, only these formulas are to be useful in your syllabus and in your problems. So I will be solving in your exercise. There are maybe approx 10 problems or something. I have taken 4 important problems and 4 basic problems that to be known by you. So going to the first problem. I will be solving problems in this. After this concept, I will be going to the trigonometric identities. With that, your trigonometric chapter is done. So note down the first problem, problem number 1. Problem 1. So what is the first problem? Evaluate first one. And first problem, first one, sine of 18 upon cos of 72, and the second one is tan of 26 upon tan of 64. No, cot of 64. Yeah, this is a problem. I am doing the problem. Just observe clearly how I am doing so that you can get an idea. Solution. Taking the first problem, first one, sine of 18 upon cos of 72. In this problem, 18 can be written as, I am writing 18 as 90 minus 72. Okay, is it right? 90 minus 72 is nothing but 18. So instead of in place of 18, I am writing this one. So sine of 90 minus 72 is equal to how much? We know using this formula. Sine of 90 minus theta is equal to cos theta. Here 90 is 90 and theta is 72. So it can be written as cos of theta. Here theta is 72. Instead of sine 90 minus 72, I am writing cos 72. So instead of sine 18 by cos 72, I am writing, instead of sine 18, I am writing cos 72. So cos 72 upon cos 72. Both are same, cancels, and it will be 1. First problem is done. So I'm going to second problem. In second problem, what is second problem? Similarly as the first problem, tan 26 upon cot 64. Similarly here also I am taking 26 is equal to 90 minus 64. 26 can be written as 90 minus 64. So instead of 26 I am writing 90 minus 64. Tan 90 minus theta is equal to cot theta. So tan 26 is equal to tan of 90 minus 64, which is nothing but tan 90 minus theta, which is nothing but cot theta. Cot theta is nothing but theta here is 64. So instead of tan 26 we can write cot 64. Instead of tan 26 I am writing cot 64. So cot 64 upon 64. Cot 64. Both will be cancelled. Answer will be 1. First problem is done. So going to the next problem. What is the next problem? In the next problem is we have to show, there will be given some expressions. We have to show that expressions. We have to prove that expression is true. So going to the problem 2. Problem 2. What is the problem to show that? Show that tan 48 degrees into tan 23 degrees into tan 42 degrees into tan 67 degrees is equal to 1. We have to prove this, and this is the first problem. In that, the second problem is cos 78 degrees into cos 52 degrees minus sin 38 degrees into sin 52 degrees. These will be similar problems is equal to 0. These will be similar problems. I will be doing only the first problem. We have to solve the second problem. By how I am solving this, see, I will be solving this. You have to solve this. Okay. Take any two angles which the sum will be equal to 0. Here see, 48 and 42 sum will be equal to 0. So make this as a couple, and 23 and 67 will be equal to 0. So make this as a couple. Okay. Wherever it may be, even when you go anywhere, if you see any problem, take the angles, those two are equal to 90. So here 48 plus 42 is equal to 90. So 40 instead of 48, we can write 90 minus 42. Instead of 23, we can write 90 minus 67. So substituting in place of 48, 90 minus 42, in place of 23, 90 minus 67. I am substituting tan 90 minus 42 into tan 90 minus 67 into tan 42 into tan 67. This is tan 90 minus theta, which is nothing but cot theta, which is nothing but cot 42, and into this is nothing but cot 67 into tan 42 into tan 67. I have already given some thing which is nothing but tan theta is equal to 1 by cot theta, and cot theta is equal to 1 by tan theta. You can write this. So I am applying this thing here. So cot 42 is nothing but 1 by tan 42, and cot 67 is nothing but 1 by tan 67, and into tan 42 into tan 67. These two will be cancelled. These two will be cancelled. Answer is 1. We got the second problem also. We did the second problem also, and now we are going for the third problem. I'm writing the third problem. Yeah. Getting third problem. Problem number 3. Problem number 3. Yeah. This is problem number 3, and the problem number 3 is if tan 2a is equal to cot of a minus 18 degrees, where 2a is acute angle. 2a is acute angle. Find angle A. Find angle A. This is the problem I am going to solve now. Simply we can write what we can write. We know solution. We know that tan 90 minus theta is equal to cot theta, and cot of 90 minus theta is equal to tan theta. Here see, I am writing in reverse. I am writing tan theta as 90 minus theta here instead of tan 2a. So I am taking theta is equal to 2a. Therefore, instead of tan 2a, it is written as cot 90 minus theta, right? Instead of theta, I am writing 2a. Since I have taken theta is equal to 2a. Cot 90 minus 2a, which is equal to cot a minus 18. So cot of 90 minus 2a is equal to cot of a minus 18. Since both the ratios are equal, so 90 minus 2a is equal to a minus 18. Bring this side and bring this side. So 90, this minus will become plus 18, this minus will become plus 2a, a plus 2a, which is nothing but 3a is equal to 108, right? So a is equal to 36. So a is equal to 36 degrees. So, but he's finding, we have to find the angle here, so we got angle here, right? A is equal to 36 degrees. This is the problem 3, and the fourth problem is very important problem. You have to do. We have to observe clearly, and I am doing the problem 4. This is a problem 4. Problem 4. If angle A, angle B, angle C are interior angles of a triangle. Interior angles of a triangle. exterior angles of a triangle ABC. Then we have to show that sine of B plus C by 2 is equal to cos of A by 2. With this, concept is done, which is nothing but trigonometric ratios of the complementary angles. Then after this problem, we are going to trigonometric identities, which is nothing but sin square theta plus cos square theta is equal to 1, and other things. See how we are going to do. Solution. Since ABC, just initially draw a triangle. This is a triangle A, B, and C. I am writing angle A plus angle B plus angle C is equal to 180 degrees. Since sum of the interior angles of a triangle is 180 degrees, I am writing this. So here we need B plus C. So I am making this as this side. So angle B plus angle C is equal to 180 degrees minus angle A. I am writing simply B plus C is equal to 180 minus A. Okay. So sine of, before sine of, divide the expression. This is the expression we got, right? Divide the expression, but here not B plus C. By 2 is also there. So I am making by 2. Divide the expression with 2. So I am dividing. So B plus C by 2 is equal to 180 minus A by 2. Here I am splitting 180 minus 2 minus A by 2. So 180 by 2 is nothing but 90. 90 minus A by 2. So apply sine on both sides. Applying sine on both sides becomes sine of B plus C by 2 equal to sine of 90 minus A by 2. Here A by 2 is nothing but theta type. So sine 90 minus theta, remember the formula cos theta, which is nothing but cos A by 2. Hence proved, which is sine of B plus C by 2 is equal to cos of A by 2. With this, your trigonometric ratios of complementary angles is completed. Then our next concept is trigonometric identities. This coming to the next concept. Our next concept is trigonometric identities. Since I said the same, next concept is trigonometric identities. Here we are going to derive only 3 formulas which are so important for your problems. I'm going to do the 3 right. I'm going to write the 3 formulas what we are going to derive. Sin square theta plus cos square theta is equal to 1. And second one, 1 plus tan square theta is equal to secant square theta. Third one, 1 plus cot square theta is equal to cosecant square theta. These are the 3 formulas we are going to derive in the trigonometric identities. With these 3 formulas, your chapter is done, and doing some 4 to 5 problems or with these formulas there are many problems, and you have to observe clearly. I'm going to explain about 10 problems. Observe those problems. These may be important in your exams. Okay. And now we are going to derive these 3 identities. Before going that, in this chapter, since I said right angle, if for any problem draw a right angle triangle, I'm taking a right angle triangle, naming it as triangle A and B and C, which is right angle at B. I'm naming it as if I'm taking suppose angle C as theta, then it is known as opposite side, and this is known as adjacent side, and this is known as hypotenuse, HYP, hypotenuse. Since what we have know from the Pythagoras theorem, what is the Pythagoras theorem? You know already Pythagoras theorem, right? By the Pythagoras theorem, AB square plus AC square is equal to BC square is equal to AC square. What is the Pythagoras theorem? AB square plus BC square is equal to AC square. From the Pythagoras theorem, I am writing Pythagoras theorem. From the Pythagoras theorem. Okay. uh, from this since this is a basic thing, from this I am writing what is sin theta. Sin theta is equal to AB by AC, right? What is cos theta? Cos theta is nothing but BC by AC. Okay, this is the expression. I am going to write the expression again. What is the expression? Initially we got AB square plus BC square is equal to AC square. Now dividing the total, this is the expression 1 we got. Dividing the equation 1. Dividing the equation 1 with AC square. I am dividing the total expression with AC square. So AB square plus BC square upon AC square is equal to AC square upon AC square. AC square will be cancelled. This will be become 1. I am splitting this. AB square by AC square plus BC square upon AC square is equal to 1. I am just making the square as a common. I am writing C. How I am writing? AB by AC whole square I am writing. Okay, this is okay, right? Plus BC by AC whole square is equal to 1. If you observe clearly, AB by AC is sin theta and BC by AC is cos theta. I am substituting that. AB by AC is nothing but sin theta, which is nothing but sin square theta, so it's nothing because square is there, plus cos square theta is equal to 1. The first identity is proved. Okay, this is the first identity. Okay, we got the expression, right? This is the expression 2. Now divide the expression 2. Divide the expression or the equation 2 with cos square theta. I am dividing with cos square theta. Then sin square theta plus cos square theta by cos square theta is equal to 1 by cos square theta. I am just splitting this. 1 can be written as 1 square. I am writing square as common. I am taking 1 by cos theta whole square. So 1 by cos theta is nothing but secant theta. So secant theta, secant square theta, because square is there. I am splitting this. So sin square theta by sin square theta upon cos square theta plus cos square theta upon cos square theta is equal to secant square theta. Cos square theta will be cancelled. I am taking square as common. What will become then? Sin theta upon cos theta whole square plus 1 is equal to secant square theta. This will become 1 plus tan square theta is equal to secant square theta. This is the second expression we have to prove. The second expression is also proved. Then what is the third expression? For proving the third expression, I am taking again this expression. What we got expression sin square theta plus cos square theta is equal to 1 we got. I am taking this expression again here. We got 1 plus tan square theta is equal to secant square theta. For proving 1 plus cos square theta is equal to cosecant square theta, I am taking the same expression. Sin square theta plus cos square theta is equal to 1. Now divide this expression. Divide with sin square theta. I am dividing it with sin square theta. So it will become sin square theta plus cos square theta upon sin square theta is equal to 1 upon sin square theta. So similarly, split this sin square theta upon sin square theta plus cos square theta upon sin square theta. I am writing 1 by sin theta whole square. Sin square theta will be cancelled. This can be written as cos theta upon sin theta whole square is equal to 1 by sin theta is nothing but cosecant theta whole square. This can be written as 1 plus this is nothing but cot theta. Cot square theta is equal to cosecant square theta. Right? This is the third expression we have to prove. The third expression is also proved. With this, your syllabus is done. I am going to do some problems. With that problems, your trigonometry chapter is going to be done. So I am starting the problems here. The first problem will be problem 1. This is the problem 1. What is the problem 1? Express trigonometric ratio sin A, secant A, tan A in terms of cot A. Express trigonometric ratios sin A, secant A and tan A in terms of cot A. Right, this is the thing we have to prove. Express the trigonometric ratio sin A, secant A and tan A in terms of cot A. I'm going to solve this problem, though, so observe clearly how I am doing. Okay, how we can do sin A? We have to represent it in terms of cot A. I'm writing f of, I think you don't have knowledge of that. So how we can write this? Okay, we know the relation tan A is equal to sin A upon cos A, right? I hope you know this. And we know the relation sin square theta. Instead of theta, I am using a sin square A plus cos square A is equal to 1. So instead of sin square A is equal to 1 minus cos square A with this. Sorry, A. It implies sin A is equal to root of 1 minus cos square A. You are not getting this, so this is wrong. Okay, I'm going in another procedure. Sin A is equal to 1 by cosecant A. We can write like this, right? But we know the relation. What we know the relation? 1 plus cot square A is equal to cosecant square A. With this, I will write cosecant A is equal to root of 1 plus cot square A. I am substituting cosecant A place of this. Okay, I am writing 1 by, instead of cosecant A, I will write this 1 by root over 1 plus cot square A. So I represented sin A in terms of cot A. So the first one is done. So what is the second one? Second one is representing secant A in terms of cot A. I am writing secant A in terms of cot A, right? How to write